Hello everyone. In this video we're going to find the critical points of a function. So let's just take a little bit of an aside here for a moment and just remind ourselves what a critical point is. The function f has a critical point at x equals c if f prime of c is equal to 0 or f prime of c is undefined. All right, so that's what we're looking for. We're looking for where the derivative of this function is either undefined or the derivative is equal to 0. And this is the definition of a critical point, so I guess I should call that, I'll just call that, I'll write definition here. Okay, so got that, and put that on its little side over there on the side. Okay, so now we're back to our function. Well, one of the things we might want to do is just do a by the way, another aside, remark. The domain of f is all real numbers. And why, I mean, how can we see that right away? Well, you could write f of x is equal to, it's equal to x to the 1/3, but that's the cube root of x. And we can take cube roots of negative numbers. For example, the cube root of -1 is -1, because -1 to the third power is -1. The cube root of -8 is -2, because -2 to the third power is -8. So anyway, we can take cube roots of negative numbers and positive numbers. So this function f has domain all real numbers. I also want to point out that when we say that function f has a critical point at x equals c, well, it's important that c is in the domain. So we're looking for critical numbers c where, and that means where the derivative is equal to 0 or the derivative is undefined, where c is in the domain. Okay, I mean, so if f of c is undefined, then f prime of c would be undefined, but that wouldn't be a critical number. Okay, now let's get to business, and so I suppose you could have just fast forward the video up to this point. Well, so here's our solution then. Okay, so step 1, find f prime of x. This is, well, I think compared to many other things, this is straightforward because we use the power rule. So we take the derivative. Okay, so I just rewrote f. So it's sitting right above. And so the way we take the derivative is the power rule, which means the 1/3 comes to the front. And then I have x to what power? Well, I take this 1/3 and I subtract 1. I can show that work, which I think is a little bit too much. I mean, writing 1/3 minus 1, I don't like the way it looks, but I can do that. Then I'll write out this 1/3 minus 1 in the next line. Then I come to this next x to the 4/3. I bring 4/3 to the front. And then I have x to the 4/3 minus 1. So that's the power rule, where I bring the power to the front. It has to be x raised to a power. So x, and I bring the exponent, the 4/3 to the front. And then I take 4/3 and subtract 1. And remember that 1 is 3/3. So f prime of x is 1/3 x to the 1/3 minus 3/3 makes -2/3 minus 4/3 x to the 4/3 minus 1. 4/3 minus 3/3 is 1/3. Okay, there's two things we want to do. We want to find where the derivative is undefined, and we want to find out where the derivative is equal to zero. Okay, then, so there's different ways to do this, but what I am going to do is I am going to write this as a single fraction. You don't really quite see the fraction yet, but see, this x to the minus 2/3 power can be expressed as 1 over x to the 2/3. And we have the 1/3 there, so I'll put 3 there. So that way I have a fraction, and what I plan to do is to write these two together as a single fraction. There's different ways to do this, but that's the way I'm going to do it. And so I get a common denominator, which, sort of know about that, don't we? So we both have we have a 3 on each of these. What I need is each of those denominators to have 2/3. So I'll just take the second fraction, and I will multiply both the numerator and the denominator by 2/3. I'll even put a different color so that sort of stands out as that's what I'm doing. Okay, and so back to this. So that in the denominator, then I get 3x to the 2/3. And then in the numerator, I have 1 minus 4x to the 1/3 times x to the 2/3. Well, can I also do this step where I add the exponents because I'm multiplying? So I have 1/3 plus 2/3, which I think, people can do in their head, but I just wrote that out. So 1/3 plus 2/3 makes 3/3, which is 1. So x to the 1. Okay, so step 2, solve f prime of x equals 0. So for us, that's going to be 1 minus 4x over 3x to the 2/3 equals 0. And what I do is I look at the numerator to see where the numerator is equal to 0. So a fraction is equal to 0 when the numerator is equal to 0. And so I get 1 equals 4x, so therefore x equals 1/4. And that is one of our critical numbers. So that's one critical number. And then the other one is step 3, where is f prime of x equal to 0? Where is f prime of x undefined? Now, for many problems, exercises in textbooks, it's the f prime is defined for all real numbers or everywhere in the domain of f. So that's not always, there's a lot of times the answer is nowhere. It's defined everywhere on the domain of f. But in this situation, we have f prime of x equals 1 minus 4x, 3x to the 2/3, and we have a fraction. And whenever we have a fraction, we're looking at domain issues, or where is f prime undefined, we should ask ourselves, well, what about the denominator? So 3x to 2/3 equals 0 when x equals 0. So do you see that because putting an x equals 0 in the denominator gives 0 in the denominator, then that fractional expression is undefined there. You can't have 0 in the denominator of a fraction. It's undefined. So f prime of 0 is undefined, and it's also in the domain of the original function. That's important. Okay. So f prime of 0 is undefined. So and it's also in the domain of the original function. Sometimes we'll find a point where a number where it gives 0 in the denominator of f prime, but it turns out that that number was not in the domain of the original function anyway. So, our summary then, this is step 4, something like that, summary. F prime of 1/4 is equal to 0. So x equals 1/4 is a critical number. And by the way, I'm saying critical number, critical points. When the domain is R, or maybe an interval in R, we sometimes say critical number and sometimes we say critical point. F prime of 0 is undefined. So x equals 0 is a critical point. So that is that's that's it. So again, overview is you take your function and you find its derivative. You look to see where the derivative is equal to 0, and you look to see where the derivative is undefined. The places where f prime is equal to 0, those numbers, those are critical points, and the places where f prime is undefined, those are critical points. And so these problems can be sort of simple if the derivative is easy to find, and when it's easy to solve f prime of x equals 0, that's an easy problem. But some of them can be, quite difficult if it's a difficult derivative and if it's difficult to solve the equation f prime x equals 0. So you start off with, if you go through a homework set, exercises and books, they start off with easy ones and then they get more difficult. Sort of trying to get everything in the last bit here, but maybe that's not possible. But okay. So that's one example with critical points. Thank you.